Hi, my name is Sebastian Matteau, and today I would like to show you 7 simple tricks that you can use to make your Python code easier to read, simpler, and just in general more beautiful. All of these are solutions to very simple but common problems that you encounter while writing Python code, and that people tend to solve in suboptimal ways. So I will show you several simple ways just to efficiently solve little problems that you might encounter. I do this in Python 3.4, but all the tips and tricks are equally applicable to Python 2.7 or whatever kind of version of Python that is currently used by most people. Right? Let's start with the first trick, and this is a very common scenario in which we have a list. In this case, a list of cities, and we want to walk through this list of cities, while printing them out, for example, to the terminal, and also printing out their position in the list, right? So we want to get all the items from the list and their positions. Now, a very common but bad way to solve this problem is to create a counter variable, I, which starts out at 0, right? Because the first position in the list is position 0, not position 1, but 0. And then we walk through all cities in the list, so for city in cities, we print out the counter variable and the name of the city, and then we increment the counter variable by 1. Now, if I select this and execute it, you see here in the terminal that this works, right? So it prints out 0, Marseille is the first city in the list, Amsterdam is the second one, New York is the third one, and London is the fourth one. So it works. But it is bad because it's quite difficult, moderately difficult to grasp the logic at first sight, and we create this counter variable that we don't really need. So let's take a look at the good way, the Pythonic way to do this, and that is using the enumerate function. So what we can do is, instead of walking directly through the list of cities, we can pass the list of cities to enumerate. And enumerate returns a list of indices and city names, right? Print y city. So basically, enumerate first returns 0, Marseille, then it returns 1, Amsterdam, then it returns 2, New York, and then it returns 3, London. And if I select this and I execute it, you see here in the debug window that it works. It does exactly the same thing as the bad way, but it is easier to read, and it avoids 2 lines, and it also avoids this temporary counter variable. So the bottom line is that whenever you have a list and you want to walk through this list and at the same time keep track of the positions in this list, you should usually use enumerate and not create a kind of a counter variable as you see here in the bad way. Now, let's move on to scenario or tip number 2, which again has to do with lists. And the scenario is the following. Say that we have 2 lists, for example, a list of x coordinates and a list of y coordinates, and we want to walk through these 2 lists at the same time, for example, to print, to draw a dot at these coordinates, right? So we want to first get the first x coordinate and the first y coordinate, then next time get the second x coordinate, the second y coordinate, and then get the third x coordinate and the third y coordinate, right? So instead of first looping through the x list and then looping through the y list, we want to loop through both lists at the same time. Now, this is quite a common problem, and I think you'll usually see it solved in this kind of awkward way that you see here. So what you can do first is get the length of x list, which is 3, right? Because there are 3 items. Then we create a range from 0 through the length to the length of this list. So we get basically 0, 1, 2. And then we loop through that, right? So it is basically for I in 0, 1, 2. That's what it says here, even though it's quite difficult to read. Then we get the x coordinate at the position that we're currently at, right? So we get, for the first time we get 1, the second time we get 2, third time we get 3. We do the same for the y coordinates, so the first time we get 2, then 4, and 6, and then we print them out. Now, if I select this and run it, then you see here in the terminal, you see that it works, right? So the first x and y tuple basically that we print out is 1 and 2. Then we print out 2 and 4, so 2 and 4. And then we print out 3 and 6, so 3 and 6. So it does what we want to do, but it is very difficult to read, right? Especially this range len xlist thing is quite horrible. So the good way to do this in Python is to make use of the zip function. So what we can do is for x, y in zip xlist, ylist, and then we say print x, y. So what zip does is it takes 2 or more lists and it really zips them together. So it basically creates tuples that pair items at the same positions in all of these lists, right? So it pairs 1 with 2, it pairs 2 with 4, and it pairs 3 with 6. And then basically you can say, okay, walk through each of these pairs. So the first time is x is 1, y is 2, the second time x is 2, y is 4, etc. And then we can print it out. So if I select this and I run it, you see that it does exactly the same thing as before, right? The only thing is that it is shorter. We have saved 2 lines of code and it is much more readable, right? So the bottom line is that whenever you have 2 or more lists and you want to walk through these lists at the same time, you probably want to use zip instead of devising a kind of an awkward, ugly range construction that you see below. Now, let's move on to scenario number 3, which again is a very common scenario, and it is the following. Say that we have 2 variables, x and y, and we want to swap their values. So we start out with x being 10 and y being minus 10, but we want to swap this so that x becomes minus 10 and y becomes 10. Then what you usually do is you use this kind of, or what most people do is use this kind of temporary variable. So we assign the value of y to temp, then we assign the value of x to y, then we assign the value of temp to x, and then we've done the swap, right? So we need this temporary variable to make sure that we don't lose one of the values during the swapping. Now if I select this and I run it, you see that it works, right? Before x is 10 and y is minus 10, and afterwards x is minus 10 and y is 10. So it works. But it's bad because we have the swap took us 3 lines, and it is and we also needed to create this temporary swapping variable. So the good way is as follows. I'll comment out the bad way. Up. The good way is simply do this. xy is y, x. And we can do the whole swap in one line. And this is a trick that is very peculiar, very particular to Python, and it is really cool. It's called tuple unpacking. So what we do first, we create a tuple, so a pair of values. First the y coordinate and then the x coordinate, and we unpack it to the left hand side. So basically it means y gets assigned to x and x gets assigned to y. And because this whole line happens at the same time, right? It happens instantaneously in a sense. We don't need this temporary swapping variable temp that we needed before, right? Because we don't lose any of the values in the swapping process. Now, if I take this and I execute it, you see that it does exactly the same thing as the bad way. So x goes from 10 to being minus 10, and y goes from minus 10 to being 10. But it is better because it is only one line of code, and it is also, in my opinion, much easier to read. Now, you can do the same trick if you want here. So instead of saying x is 10 and y is minus 10, you can say x, y is 10, minus 10. Right? So whenever the number of items basically on the right hand side matches the number of things that you unpack on the left hand side, and this also needs to be tuple, a particular Python data type, you can use this kind of tuple unpacking or multiple assignment or whatever you want to call it. Right. So I'm not sure whether in this case it is worth it, but in this case it is definitely worth it. So whenever you want to swap variables around, using this kind of tuple unpacking can be a very convenient tool to use. Okay, now let's move on to scenario number 4, trick number 4, which has to do with dictionaries. Again, a very common problem that many people run into. So say that we have a dictionary, in our case a dictionary of ages, and the names are the keys and the ages are the values. And we want to get the age of one person, Dick in this case, but we are not 100% sure whether Dick is actually in the dictionary. That's a problem, because if we just say, okay, age is ages Dick, right? Yep. I select this and I run it. Then, of course, it crashes with a key error Dick, because Dick is not in this dictionary. Now, most people are aware that you need to check, therefore you need to check whether Dick is actually in the dictionary, and it can be done in the following way, in the following bad way. You can say, okay, if Dick is actually in the dictionary, then we get the age of Dick from the dictionary, else we fall back to a default value called unknown. And if I select this and I run it, you see it works. It says Dick is unknown years old, right? And if I add Dick to the dictionary, Dick, it will say, and I select it, execute it, it will say Dick is 51 years old, right? So it gets Dick from the dictionary. So this works. In that sense, it's fine. But it's ugly because we have these 4 lines of code just to get something from the dictionary. So we can do it better. And we can do it better in the following way. We can make use of the get function. Okay? So what I'm typing here is the good way. The good way. So let's comment this out. Okay? So what I'm doing here is basically getting the age of Dick from the ages dictionary, but if Dick is not actually in this dictionary, we fall back to a default value unknown. So this single line expresses the same logic that took us 4 lines here, right? So basically gets a value from a dictionary, but it also takes a default value to fall back to if the value is not in the dictionary. So it's a very convenient function to know about. Now, if I select this and I execute it, you see it works. Dick is 51 years old. If I remove Dick here from the dictionary, select it, run it, it will say Dick is unknown years old, right? Because Dick is no longer, I commented Dick out of the dictionary, right? So whenever you want to get things from a dictionary, but you're not actually sure whether the thing that you want to get is in the dictionary, it is nice to use the .get function of a dictionary, which takes a default value in case the value is not in the dictionary. Okay, so let's move on to trick number 5, scenario number 5, which has to do with for loops. And I think very few people are familiar with this particular trick. Now, let's take the following scenario in which we have a needle, the letter D, and we want to search a haystack, which is a list of letters, to see if D is actually in this list. Now, of course, we can do this just by asking if needle in haystack, but that's not what we're going to do here. We're going to use this little search demonstration to make a point. So let's start with the bad way. So what can we do? We can start out by creating a marker variable called found and assuming that the needle has not been found. So we start out by saying found is false. Then we loop through each letter in the haystack, and if the letter matches the needle, we print out found to the terminal. We set the marker variable to true, and then we break the list. We break the loop, right? And then at the end of the loop, we check our marker variable to see if the needle was found, and if not, we print out not found to the terminal. So if I select this and I run it, it prints out not found, which is correct, right? Because our needle D is not in the haystack. If I add the needle to the haystack and I run it, it will say found, which is again correct because, of course, now the needle is actually in the haystack. But this is bad because we have this marker variable, which is unnecessary, and it also makes the whole logic of the thing a little bit more difficult to understand. So how can we improve this? Well, we can make use of the fact that Python for loops have an else statement, which is a bit odd but very powerful. So what is the good way? The good way is to start out by removing this marker variable here and here. And then instead of saying if not found, we say else. And what else basically means here in this context, or in any context, is if no break occurred, right? So this, whatever is under else, is only executed if no break statement occurred during the loop. So what we have is the following logic. We loop through the haystack. If we encounter the needle, we break and therefore do not execute this. However, if we loop through the entire haystack without encountering the needle, we have not broken and therefore no break occurred, and we execute this print not found. Right. So if I select this and I execute, it will say found because the needle is in the haystack. If I remove the needle from the haystack and I select it and execute, it will print not found, right? So because the needle is no longer in the haystack. So this works. It does exactly the same thing as the bad way, but it is better because it is less lines of code. We don't need this marker variable found, right? And it's just overall more easier to understand. So the bottom line is, if you want to do something when you've at the end of a loop, only if the loop was completely finished, and this happens quite a lot, right? Then you should use the else statement in combination with a for loop, right? So you should think of else as if no break occurred. So that's a very convenient trick to know. Okay, so let's move on to trick number 6, which has to do with file reading. Now, a very common thing to do with a text file, if you have a simple script, is to read a text file and to process each line from the text file one by one. So let's say that we have the lyrics from Pimpin' Ain't Easy by Ice-T, and we want to read those lyrics and print them out one line at a time. Then we can do something like the following in a bad way. So what we do is we open the text file, we read the context of the text file and we save it in the variable text. Then we split the text by /n. So since /n is a line separation, so basically we split the entire text up into individual lines. And then we walk through all of these individual lines and we print them out to the screen, and then afterwards we close. Now if I select this and I run it, you see here in the terminal that it works, right? So take a look at me, everything I own is iced out, pimp baby, you can see my wrists with the light out. This is how I do it, mad bitches in clothes, Godfather baby, only play to my rogues. So that works, but it is bad. It is bad in two ways actually. The first is that we don't actually, the file object is quite sophisticated and we don't need to read the entire text. And we don't need to manually split it. We can just loop directly over the file object. So basically the file object supports it. You can use a file object as an iterator. You can loop through it and it will return you individual lines. So if I select this and I run it, you will see it also loops through all of the individual lines. The only difference being that in this case the line separations are not stripped off, which is why you see actual additional blank lines. So this is the better way, the somewhat better way. But there is an even better way. What we can do is make use of a so-called context with the with statement. And it goes like this: with open Pimpin' Ain't Easy.text sf for a line, and then we remove the close statement. So what this means is that everything that is under with, so these two lines, are a context, are executed in a context, and which means, it sounds very sophisticated, but it just means basically that before this is executed, the file is opened, and after this is executed, the file is automatically closed. So the with statement basically allows us to do something without having to bother with cleaning up afterwards, right? Closing a file is a way of cleaning up. And if we use a with statement, if we use a context, then we don't need to bother with cleaning up. So if I take this and I execute it, you see that it still works, right? Still prints each of the lines out to the terminal. So especially you will not, usually in Python you don't encounter contexts that often. So many people may not be familiar with the with statement, but especially when working with text files or files in general, using the with statement is very powerful because it just makes the logic of your code cleaner and easier to read. Right? Okay, so let's move on to the seventh and final trick, which is maybe not so much a trick as a bit of an explanation about try and except statements. Right? So catching exceptions, catching errors that occur in your program. Now let's say that we want to convert something to an integer. Right? So say that we want to print, okay, we print out to the screen converting, then we convert the string 1 to an integer. So we take a string 1 and we turn it into the number 1, right? So we change the data type, we print it out to the terminal, and then we say done. I select this and I execute it, say okay, converting, print out the 1, and then okay, done. That's fine. But let's say that we, instead of trying to convert 1, we try to convert x, then we run into problems. If I take this and execute it, you see we get a value error, right? Because you cannot convert a string x to an integer. That's just not possible. Python doesn't know how to do that. So then what you need to do, and I think most people are familiar with that, is you use a try except statement. So you say try except, and for example we say print conversion failed. And then if we take this and we execute it, you see it prints out conversion failed, but the whole program doesn't crash anymore, right? So we capture the error that occurs and then we just let the program continue. That's nice. But what you can also do is use the else statement. And that I think many people do not know. So conversion successful. And else is basically the opposite of except. So if no except. So basically we try to convert this to an integer. If it doesn't work, we print out conversion failed. If it does work, we print out conversion successful. And then at the very end, we print out done. So if I select this, execute it, nothing changes, right? Because it fails to convert the x, so it prints out conversion failed. But if I, for example, change this to 1, I select it, execute it, you see it says converting, then prints out 1, then prints out conversion successful, and then says done, right? So the try statement, just like the for loop, quite surprisingly supports an else statement, which in this context just means if no exception occurred. The try statement even supports another statement called the finally statement. And finally basically means always. Print, well, we can just move this print statement up here. So whatever is under the finally, in the finally block, is always executed regardless of whether an exception occurred or not, and also regardless of whether the conversion was successful. Now, so basically you can think of it as follows. We try to do the conversion. If it didn't work, we print out conversion failed. If it did work, we print out conversion successful. But regardless of whether it worked or not, we print out done. So if I select this, execute, you see it says converting 1, conversion successful, done, just like before, basically. Now, the finally statement may seem a little bit pointless because you could just as well do this, right? Does the same thing in this case. But it does serve a purpose in the following way. Let's say that we have a try statement, but we have no except and no else statement. So we have this. We have only a try and a finally. Then if I take this, I execute it. Alright, it works now, but say I change this to an x, so an error occurs, I execute it. Right, so we get a value error. And then, if we scroll up a little bit, you see that the done, which comes from here, is still executed. And the logic is the following. And it's very, very convenient to know. So if we try this and an error occurs, then before this error is actually propagated up in the program, so before basically the program crashes, we still execute whatever is under finally. So it's kind of you can kind of put your cleanup code here. So imagine that you have an open file here and you're trying to do some stuff with the file, but an error occurs. Then you nevertheless want to close the file usually. And then you can do that under finally, right? Because finally is executed even if an exception occurred. So that's a very convenient cleanup function, right? So in this case, done is printed out, Whereas if I would have just done, basically would have just done this, so just remove the whole, then done wouldn't have been printed out, because as soon as this line causes a crash, the whole program stops. So try, you can not only have a try except, but you can have a try except else, or you can have a try except else finally, or you can even just have a try finally. So try is very versatile construction that you can use in various ways to handle exceptions that occur during the execution of your program. Okay, well, that was it. I hope you found it useful, and thank you for watching.